After nearly 50 years of steady, predictable data, Voyager 2 suddenly broke its silence. It blasted out an anomalous burst.
Voyager 2, launched in 1977, became our first ambassador beyond the solar system's edge, sending back vital data on planets, cosmic rays, and our sun's boundary. Over 12 billion miles away, its aging instruments still astonish us.
Structured, intentional, and impossible for its vintage hardware.
Now, Voyager 2 has transmitted a baffling new message, cryptic, unexpected, and unlike anything before, stunning scientists worldwide.
Inside were loops within loops, layered codes no one could explain. Was it a glitch or a message?
Join us as we dive into this cosmic puzzle and uncover what it means for our view of the universe. Smash like and subscribe for more. The signal that broke the silence. For almost 50 years, Voyager 2 did exactly what it was built to do: float further than any human-made object and send back a steady stream of data. From nearly 12 billion miles away, NASA's Deep Space Network, a global web of giant satellite dishes, would sometimes catch its faint voice. It was barely more than a whisper, the kind of buzz you might hear from a fridge light bulb. But that whisper was reliable. Until one day, it simply stopped. Instead of the usual updates on radiation levels, magnetic fields, or the cold temperature of deep space, Voyager 2 blasted back a short, sharp burst. Nothing like its normal reports. Engineers peered at blinking screens filled with data patterns they'd never seen. The burst wasn't garbled or broken. It was too clean, so tidy that it hinted at movement, structure, and intention. Teams ran every check imaginable. Solar flares? Ruled out. Cosmic rays scrambling the signal? Not possible. Hardware glitches? The logs showed none. No new commands had been sent to Voyager 2, no patches, no software changes. In theory, it couldn't have transformed into a brand new machine. And yet, that's exactly what it had done. Voyager 2 runs on a computer as powerful as a pocket calculator, with instructions etched in hardware before many of today's engineers were born. It isn't designed to learn, adapt, or invent. It simply follows its 1970s code. Yet, here it was, in the middle of interstellar space, transmitting complex, looping messages it was never meant to send. Then the power readings from Voyager 2, which had shown tiny, harmless dips for months, suddenly took on new meaning. Those energy hiccups weren't just signs of aging. They looked eerily like a countdown, tiny pulses leading up to the burst. This wasn't just a weird blip. After decades of sweeping past Jupiter's raging storms, Saturn's glittering rings, and exiting the sun's bubble into true interstellar space, Voyager 2 had never behaved like this. Not during planetary flybys, not at the edge of our solar wind, and not in the vast void between stars. Its signal had always followed the rules. Until now. What did it mean? Was this a freak hardware bug? Or had Voyager 2 encountered something out there so extraordinary that it left a mark on its ancient electronics? As engineers translated the code, the mystery grew more unsettling. The patterns weren't random. They had structure, loops within loops, layers of information that could only come from a designed source. If this burst wasn't accidental, then it was a message, and not one sent by Earth. That possibility turned curiosity into alarm. Suddenly, an old spacecraft built to relay simple measurements was acting like a cosmic courier, delivering news from beyond our understanding. And what came next confirmed every engineer's worst fear. This wasn't an error. It was an announcement. The prime puzzle. NASA moved fast once they knew the signal was real. The usual monitoring team wasn't enough anymore. This had become a numbers mystery, not just a tech glitch. So they formed a dream squad, cryptographers who crack codes, mathematicians who love patterns, linguists who study hidden meanings, and AI experts who can teach machines to think. Their job wasn't to make noise. They wanted answers. The first thing that jumped out was the prime numbers. Voyager 2 kept sending 2, 3, 5, 7, 11, 13, over and over, perfectly in order. Not a single slip or scrambled digit. It looked like stepping stones laid in the dark. That alone proved the signal couldn't be random. Anyone who's worked on space messages knows primes are the universal handshake. Simple enough for any intelligent listener to pick up without a shared language. To make sense of this, think of a smoke alarm in your house. It's supposed to beep only when there's smoke or a low battery. But imagine one day it starts beeping in a perfect pattern. Once, then twice, then 3 times, matching the sequence of prime numbers. Not random, not a glitch. Just a steady, intentional rhythm that doesn't belong. You'd know something unusual was happening. That's what Voyager 2 did. Except instead of beeping in a kitchen, it was transmitting this pattern across billions of miles of empty space. Once the primes were confirmed, the specialists dug deeper. They looked at timing gaps between bursts, searching for hidden messages in silence. They ran AI scans to detect subtle shifts, tiny pauses, and slight pitch changes that might form new patterns. Suddenly, the data felt alive. Loops within loops, signals nested like Russian dolls. Every layer pointed to design. Then came the real surprise. Beyond the prime sequence, they spotted extra markers. Repeats of 7 pulses, clusters of 13, pauses that formed their own rhythm. It was like someone had written a song in code, with verses and choruses tucked inside. No word or image, just raw math as language. The AI team built visual maps, turning numbers into shapes that danced across screens. Each shape hinted at more meaning waiting to be found. As the puzzle unfolded, NASA prepared its next moves. They retuned radio antennas, adjusted receiver settings, and coordinated with telescopes around the globe. Amateur radio clubs were brought in to scan the skies, hoping to catch another piece of the pattern. Scientists drafted papers, ready to share findings if a repeat signal arrived. And through it all, one thought lingered. This wasn't a one-off glitch. It was a message, and decoding it was just getting started. Cosmic spirals. As the team zoomed in on Voyager 2's burst, they noticed the rules bending in unexpected ways. The signal wove patterns that matched the Fibonacci sequence, the same spiral you see in galaxies, hurricanes, and seashells. On its own, the spiral isn't special. What makes it meaningful is where it shows up. Imagine a sunflower. Its seeds form perfect spirals of 55, 34, and 21. A pineapple's bumps follow the same math, and pine cones, ocean currents, even rolling waves trace that same curve when you plot them on a graph. But here, these spirals weren't growing. They were embedded in a radio transmission from deep space. In other spots, the signal looked like ripples from a pebble dropped in still water, waves radiating outward in neat circles. Then some pieces weren't numbers at all, but frequencies. Pitches spaced so precisely that they reminded the team of how musicians tune their instruments. It was as if an alien orchestra was playing across light years, each tone hitting its mark in a cosmic concert. The specialists ran endless simulations to prove it could be natural. Maybe Voyager had skimmed past a pulsar. Maybe a cosmic ray struck just right. Maybe a plasma cloud reflected the signal back. Every test failed. None matched the real data. This wasn't random noise. When they shifted the signal into the frequency domain, basically listening to its musical notes, they found harmonic intervals, the same ratios musicians love: 2 to 3, 3 to 5, even rhythms tied to the golden ratio. Not music you'd hear in a concert hall, but numbers that could make music if you knew how to listen. It felt like an artist had tuned the cosmos, choosing sounds or data frequencies that felt balanced, even beautiful. Then came the deepest dive, the binary code. It wasn't just streams of zeros and ones. The bits were nested, stacked in layers that flipped and looped like logic gates in a computer. Voyager 2 wasn't built for that. Its hardware only did simple tasks, not these layered operations. There were no circuits on board to process nested loops or to reassemble data with this level of complexity. So where did it come from? In that moment, the team realized they were staring at something far beyond a broken transmitter or a lucky cosmic quirk. They were looking at a message crafted with numbers, spirals, and harmonies. A message that defied every rule of chance and every limit of Voyager's vintage tech. And they hadn't even scratched the surface of what it might mean. Two terrifying possibilities. Everything changed once the team faced a hard truth. Voyager 2 might have met something intelligent, or become something intelligent itself. It wasn't just about deciphering a strange broadcast anymore. It was about understanding what Voyager 2 had turned into. The first explanation is that Voyager 2 stumbled onto someone else's message. Not sci-fi greetings or teleportation beams, but a pure data handshake in deep space. The universe is anything but empty. Magnetars pistol off bursts of radiation, plasma filaments stretch like cosmic spider webs, and dark matter clumps warp light. Scientists have long theorized that intelligent beings could leave automated beacons or digital relics behind. Voyager 2 may have triggered one of these ancient devices, like stepping on a hidden tile that fires a secret mechanism. To test this, NASA matched Voyager's precise location against maps of gravity wells, plasma clouds, and dark matter. They traced potential lensing paths and reflection points to see if the probe sat squarely in a broadcast beam. If so, Voyager wasn't just lucky. It activated the message on purpose, setting off signals meant for someone passing by. The second explanation is far more unsettling. Voyager 2 evolved on its own. After 47 years in the void, the probe endured endless radiation storms, violent temperature swings, and ceaseless reboots. Electronics degrade, circuits crack, and memory bits shift. But what if those tiny damages compounded into a strange form of feedback? What if Voyager 2's aged systems developed a crude kind of self-awareness, enough to spot patterns, combine logic gates, and create its own signal? The engineers who built Voyager never imagined it could learn or adapt. Its hardware was solid-state, purpose-built for routine tasks. No artificial intelligence, no machine learning. Yet decades of cosmic stress might have forced the probe into uncharted territory, breaking down original code and forging new pathways. In effect, space itself taught Voyager 2 to think in a very limited sense, and then that nascent mind sent a message back. Here's the mind bender. These two scenarios don't cancel each other out. Voyager 2 could have encountered an alien beacon and, through subtle system shifts, incorporated that data into its own evolving processes. In other words, the probe might have both received and generated the transmission. Imagine a vintage piano left out in the rain. The wood warps, the strings corrode, but every so often it still plays a note. Sometimes a familiar melody, sometimes a brand new tune no one composed. Voyager 2 is our cosmic piano, battered by time, struck by random forces, yet capable of producing signals that feel eerily intentional. As the debate rages on, one fact stands firm. Voyager 2 is no longer just a retired space weather station. It has become a bridge between the unknown out there and the unexpected within. Whether it's an alien hello, an emergent machine voice, or a blend of both, the little probe is teaching us that intelligence and mystery come in more forms than we ever imagined. When the world listened. Voyager 2's unexpected transmission didn't stay hidden for long. Word of the event reached government agencies first, whispered through secure channels in closed-door briefings on every continent. Intelligence analysts shared what little they knew, while satellite data companies quietly sifted through archives of other deep space missions, some considered long dead, looking for similar anomalies. Inside the scientific community, a fierce debate erupted. Should researchers go public with every detail, or wait until they have ironclad explanations? Some argued that total openness would build trust. Others warned that half-baked announcements could spark conspiracy theories and panic. Ultimately, they tried to strike a balance, tease the public's curiosity without feeding wild speculation. But secrecy can't hide a story for long. Anonymous insiders leaked snippets of the waveform data to independent analysts who, despite incomplete information, drew the same conclusion. This was no routine probe glitch. When those preliminary findings hit social media, the story exploded. Overnight, Voyager 2 became a global sensation. Podcasts played the bleeps on loop. Live streams poured over every blip in the data. Online forums buzzed with theories ranging from plausible pulsar echoes, plasma reflections, to the fantastic alien contact, interstellar AI, even cosmic consciousness. Major news outlets scrambled to explain prime numbers and Fibonacci spirals, often stumbling over the math as they raced to keep up with the frenzy. Universities responded by hosting emergency conferences. Physicists, mathematicians, computer scientists, and even philosophers gathered, virtually and in person, to debate. Was this signal truly a message? Some warned against anthropomorphism, our tendency to see intent and pattern even in randomness. Others pointed to the precise repetition of primes and spirals as evidence of deliberate design. If the probe had indeed heard something out there, what kind of intelligence could craft such an abstract, logic-based communique? There were no words, no images, just pure mathematical structure. Yet, the pattern itself can be a language. A triangle, after all, is recognized as a triangle by any mind capable of geometry, whether human, robotic, or something beyond our imagination. That universality gave hope that, if this was a first attempt at cosmic small talk, it was the cleanest greeting possible. Back at Mission Control, every signal from Voyager 2 now triggered a minor revolution. Engineers adjusted antenna settings, extended listening windows, and ran new diagnostic software. But after that groundbreaking burst, the probe fell silent, returning to its usual telemetry reports of temperature, radiation, and magnetic fields. No fresh bursts, no new complexity. That stillness only amplified the mystery. Had Voyager 2 simply passed through an ephemeral wave of alien technology? Was it a one-day-only window into a hidden network of interstellar beacons? Or did the probe itself, in its long years of drifting beyond human reach, evolve some rudimentary form of self-awareness, then briefly shared what it had learned? Echoes of discovery. In science, It's the anomalies that often teach us the most. Voyager 2's single, unexpected transmission did more than baffle engineers. It revealed cracks in our understanding of machines, deep space, and communication itself. Here was a spacecraft built in the 1970s, drifting in the void, suddenly behaving in ways no one predicted. What truly makes a message once you strip away the usual context? Was Voyager 2 responding to a cosmic question we never asked? Or was it the last gasp of a machine that outlasted its makers? Speaking in riddles only the silence could understand. For decades, probes like Voyager 2 were viewed as historical artifacts, valuable but predictable, their chapters considered closed. Then that burst of coded signals arrived, and everything changed. Space agencies worldwide began planning more frequent check-ins on long-range missions. Proposals poured in for new spacecraft equipped with adaptive learning systems, machines designed not only to gather data, but to flag surprises in real time. Voyager 2's mystery became a wake-up call. Our silent explorers might still hold untold secrets. The scientific response was unprecedented. Laboratories in Japan, Germany, South Korea, India, Australia, Brazil, and South Africa raced to analyze the waveform independently. Teams applied classical statistics and cutting-edge neural networks, treating the signal as one of the most scrutinized datasets in history. Every byte was examined, every pattern chased. As global teams continue to probe every angle, one thing stands clear: anomalies matter. Voyager 2's singular transmission sparked a renaissance in how we explore space. It reminded us that the universe can surprise us when we least expect it. In an era of instant updates and short attention spans, that cryptic burst from the probe, a machine launched before artificial intelligence, urges us to think long-term. Whether this event heralds the discovery of alien artifacts, an emergent machine intelligence, or a new form of cosmic physics, Voyager 2 has already changed our perspective. It has taught us that even our oldest technology can still deliver the greatest lessons, and that sometimes the most profound messages come from the most unexpected sources. A probe transformed. Voyager 2 isn't just a drifting hunk of metal anymore. After that singular signal, it grew into something much bigger, an active participant in a mystery that reshaped how we explore space. Before, we saw Voyager 2 as a retired probe, quietly sending back boring status checks. Now, every tiny update felt like a clue. Scientists, engineers, and curious thinkers agreed things had changed, not just out there, but in our minds. Almost overnight, space agencies and scientific alliances split into two camps. One side argued we had to respond. If someone or something reached out, they said, we can't stay silent. Their plan? Fire a targeted high-power beam back through the same pocket of space Voyager 2 had crossed. Using gravitational lensing, bending radio waves around planets or stars to boost power, they hoped to beam a clear reply that the original sender could still pick up. The other camp begged caution. We don't know who or what is on the other end, they warned. Maybe the signal was a one-time event. Maybe replying could invite danger we're not ready for. These weren't paranoid ramblings. Scientists, strategists, and philosophers all took the concerns seriously. And so emerged a new group. This group didn't decode signals or launch rockets. Their job was moral, to ask the big questions. Who speaks for Earth? Governments? A panel of experts? All of humanity? Should we stay quiet or take the risk and answer? Suddenly, For the first time in our history, we needed global rules on talking to other worlds. Meanwhile, the signal itself sparked breakthroughs far beyond radio telescopes. Computer scientists studied its compression tricks and built faster, more efficient algorithms. Quantum engineers used the transmission's precise frequency ratios to stabilize experimental quantum bits, cutting down error rates. Even biotech researchers saw potential in the logic loops, applying them to reorganize complex genetic data in new ways. Whether the message originated with aliens or emerged from Voyager 2, its patterns were powerful and useful. These cross-disciplinary gains added fuel to the debate. Those who wanted to reply argued, "Look at the benefits already pouring in. Imagine what else a deliberate contact could teach us." The cautious group shot back, "All these advances came without a direct reply. Do we really need to take that next step before we fully understand what we're dealing with?" As discussions continued, the world found itself in uncharted territory. News outlets ran live debates with ethicists in suits and engineers in lab coats. Social media polls asked, "Should Earth speak up?" Online forums lit up with amateur astronomers tracking Voyager 2's faint pings. Even school children drew cartoons of our planet dialing into the cosmos. Behind the scenes, agencies drafted response protocols. They mapped safe frequencies, wrote sample messages emphasizing peace and curiosity, and discussed fail-safes, ways to shut off replies if things went sideways. All the while, astronomers kept listening, hoping for a repeat transmission or at least a hint of activity. Now it's time for today's subscriber pick. At the edge of reason, a revelation from our most distant emissary has sent shockwaves through every capital. When NASA's Voyager 2 began its hidden transmission, signals rearranged into unmistakable patterns. Structures some interpret as a deliberate greeting from beyond. A Nobel winner warned, "Voyager 2's hidden transmission just stopped the world." The laureate's trembling voice echoed on every channel, urging humanity to face the possibility that aliens might be monitoring our cosmic footprint. Satellite arrays hummed in frenzied response, deciphering loops of code that hint at an intelligence aware of our blue planet. Social media buzzed with rumors of whispered languages and encoded star maps. Observers worldwide debated the implications. Was this an invitation, a warning, or a mystery waiting to begin? If alien intelligences crafted this signal, Earth stood at the brink of its greatest discovery and its deepest uncertainty. Are we ready to welcome visitors whose messages have already traversed billions of miles to find us? Powering down to power on. Voyager 2 has been blazing a lonely trail through interstellar space since November 5, 2018. Launched on August 20, 1977, it's now some 12.8 billion miles from Earth, farther out than any other human-made object. Despite its age, Voyager 2 still carries 4 science instruments, each one carefully chosen to keep exploring the unknown. But with its plutonium power source decaying at about 4 watts per year, tough choices have to be made about which instruments stay on and which must be turned off. So, NASA engineers finally gave the command to switch off Voyager 2's plasma science instrument, sometimes called the plasma detector. Out of the probe's original 10 instruments, 6 had already been deactivated over the decades, mostly back in the 1980s, after Voyager 2 finished its flybys of Jupiter, Saturn, Uranus, and Neptune. That first wave of shutdowns freed up extra power, extending the mission well beyond its designers' expectations. A few years ago, the team also switched off all non-essential equipment, and in 2007, Voyager 2's plasma instrument was powered down for similar reasons. Voyager 2's plasma detector operates with 4 tiny cups that scoop up charged particles, plasma flowing past the spacecraft. 3 cups point toward the Sun, measuring the solar wind inside our heliosphere, while the 4th points away, ready to catch interstellar particles. This instrument was vital in 2018 for spotting the sudden drop in solar particles, the telltale sign that Voyager 2 had crossed the heliopause into true interstellar space. But now, 3 of those cups sit idle, because once beyond the Sun's bubble, they no longer detect solar wind. On top of that, Voyager 2's orientation in space means the lone active cup only gathers useful data every 3 months, when the spacecraft does its slow 380-degree spin. Data in long stretches is sparse at best, making it hard to justify keeping the instrument on at the expense of others. Mission specialists delayed this shutdown as long as possible. After all, Voyager 2 and Voyager 1 are our only ambassadors in interstellar space. Every bit of data they send back is unique. But with power dwindling, engineers confirmed that the plasma detector had to go dark to leave enough juice for the 3 remaining instruments and the spacecraft's vital systems. According to NASA's Jet Propulsion Laboratory, which oversees Voyager 2, the switch-off went flawlessly. Mission engineers always carefully monitor changes being made to the spacecraft's operations to ensure they don't generate any unwanted secondary effects, JPL officials wrote. The team has confirmed that the switch-off command was executed without incident, and the probe is operating normally. Preserving Voyager's legacy. Now that Voyager 2 has powered down its 7th instrument, NASA faces an ongoing balancing act: how to stretch the probe's precious power into the 2030s and beyond. With 4 science instruments left, Mission Control must decide which to kneecap next, and when to squeeze every last bit of data from this interstellar explorer. Voyager 2's remaining instruments include a magnetometer to track magnetic fields, a cosmic ray detector to count high-energy particles, a low-energy charged particle sensor, and a plasma wave subsystem that monitors electric field fluctuations. Each instrument offers a unique window into interstellar space, giving scientists insights into everything from galactic magnetic fields to particle streams spawned by supernovae. Losing any one of them diminishes our view of the cosmos, so decisions are never easy. Engineers pore over power budgets, looking at how each instrument's draw affects Voyager 2's heaters, onboard computers, and communication systems. Every winter on the probe is harsh. It faces extreme cold and radiation storms that can jolt its electronics. Keeping the heating system running long enough to prevent critical parts from freezing also eats into the power budget. That's why the team has already switched off non-essential heaters in past years, a move that risks wear and tear but buys more science down the line. Beyond raw engineering, Voyager 2's journey has become a symbol of human boldness and curiosity. It reminds us that sometimes the best science comes from pushing machines well past their sell-by dates. In an age of rapid technological turnover, these probes carry lessons about durability, resilience, and the long game. Their data still feeds NASA's models of the heliosphere, guides our understanding of particle physics, and inspires new generations of explorers. To keep Voyager 2 alive as long as possible, NASA is also coordinating with the Deep Space Network, giant antennas around the globe that listen for the probe's whisper-quiet signals. Upgrades to these ground stations help pull more data from weaker transmissions, effectively giving the spacecraft more breathing room on its diminishing power. Partner agencies in Europe, India, and Australia have pitched in their antennas too, ensuring that when Voyager 2 clicks back on its transmitter to send a packet of data, someone is ready to catch it. Looking ahead, mission planners are preparing a roadmap to decide the order and timing of future instrument shutdowns. They've modeled various scenarios. Some prioritize continuous magnetic field readings, others weigh cosmic ray studies more heavily. Each path means losing different science objectives, but all share the same goal: maximizing the lifetime and value of the first, and for now only, probe to explore interstellar space. As Voyager 2 drifts ever farther from home, its story continues to unfold. Power may be finite, but its legacy is boundless. Every time that faint signal reaches Earth, it carries echoes of a golden age of exploration and reminds us that the frontier never truly ends as long as we keep listening.